On example 4, we're going to take a look at some trigonometric limits. First of all, you notice in the table there are two special trigonometric limits that we need to memorize. First one's limit as x approaches 0 of sine of x over x, which equals 1. And the second is the limit as x approaches 0 of 1 minus cosine of x over x, all over x, which equals 0. Start taking a look at example 4. Part A, we're finding the limit of tangent of x over x. Well, tangent of x over x doesn't match the function in either of our special limits. So let's use some trig identities. We can call this the limit as x approaches 0 of sine of x over x, sine of x over cosine of x, all over x. Now we have a fraction inside of a fraction, complex fraction. Let's make this denominator look like a fraction. And now we remember that dividing by a fraction is the same as multiplying by its reciprocal. So we can say that this is the limit as x approaches 0 of the sine of x over cosine of x times 1 over x. Well, now, the one thing we can do is remember that you can multiply values in any order. 2 times 5 is 10. 5 times 2 is 10. The commutative property of multiplication says you can multiply in any order, and you get the same answer. So to make this limit look more recognizable, we're going to reverse the x and the cosine of x and see what happens. We'll have the limit as x approaches 0 of sine of x over x times 1 over cosine of x. Okay, now, we'll look at that later. Well, now, we can all tell that the limit of sine of x over x as x approaches 0 is 1 times, and direct substitution will work for this other fraction. We'll have 1 over the cosine of 0. So we need to remember some things about our unit circle. Zero radians is right here, and our ordered pair is 1, 0. We need to remember that an ordered pair is x, y in alphabetical order, and that an ordered pair on the unit circle tells us about some trig values. Oops. And these are also in alphabetical order. Cosine of theta times, or not times, cosine of theta, comma sine of theta. So the cosine of theta corresponds to the x-coordinate. In other words, the cosine of 0 radians is equal to this x-coordinate, 1. So really, we've got 1 times 1 over 1, which is 1. Our limit for part A is equal to 1. Now, when I count down to 0, I'm going to get rid of some of the scratch work so we can work on part B. 5, 4, pause the video if you need to. 3, 2, 1. Now we're going to take a look at part B. We have the sine of 4x over x. That's our function. And we're supposed to find the limit. Now, we have a little bit of a problem because you see with our special limits that the input of the sine function matches the denominator in our special function. Now, the input of our sine function does not match our denominator. So some things that people try to do, which is illegal, is they try to factor out the 4 and call this 4 times the sine of x over x. Well, you can't do that. That would be illegal factoring. We can't factor a term or a multiple outside of the input of a function. Now, our answer is going to be 4, but let's see how come. First of all, if we come and put, let's write this problem down, limit as x approaches 0, the sine of 4x over x. If we were to come and put a 4 underneath here, now the input of our function matches the denominator. And we can take the limit. Everything is fine. Unfortunately for us, we can't just put a 4 in the denominator. That would change the value, and we're not allowed to do that. But we are allowed to do this. Putting a 4 in the denominator makes us divided by 4. So now if we multiply by 4, we're multiplying by 4 and dividing by 4. So really, we're multiplying by 1, which doesn't change any values. Now, we can see that this is going to be the limit is x approaches 0 of 4 times, and this limit as x approaches 0 is 1. 4 times 1 is 4. And that's how we would approach example 4. Moving on. In class, we tried these on our own and then checked our answers. So if you're watching this video now and you haven't tried these limits, go ahead and pause the video. Try to work these 3 limits using any techniques necessary, and then play the video to check your answers. The answers will appear in 5, 4, 3, 2, 1. On problem number 1, you can see that direct substitution works. So we'll just replace x with 4 and evaluate, and we get 9/4. Our limit as a function, our limit as x approaches 4 for this function is 9/4. Problem number 2, direct substitution fails, so we factor and cancel. Then at that point, direct substitution works. We replace x with 1, and our limit is 0. Problem number 3, a lot of people start rationalizing immediately, but it's not necessary because direct substitution works. Remember, you should check to see if direct substitution works first every time we ask to evaluate a limit. And then if direct substitution fails, then we start using our algebra techniques. Well, thanks for watching the videos. I hope this was helpful. Good luck with your practice problems.